What is zeolite? Zeolite is a microporous volcanic rock, a silicate, or more precisely, an aluminum silicate rock. In this case, silicate means that silicon and oxygen form a very solid and stable silicon-oxygen compound that is not soluble in water. The silicon oxide molecule, SiO4, has the geometric shape of a tetrahedron, which means that one silicon atom is firmly bonded with 4 oxygen atoms.
Clinoptilolite zeolite is one of over 100 variations of zeolite, the most biologically valuable volcanic rock with unique properties and various functions in the body. The zeolite properties vary depending on the geographical location and mining area. In clinoptilolite zeolite, the 3 most common elements on Earth, oxygen, silicon, and aluminum, are bound together in a very solid lattice structure, which cannot be broken up easily. Depending on the quality and the mining area, the ratio of silicon to aluminum in clinoptilolite zeolite varies, resulting in ratios of 4:1, 5:1, or 7:1. 5:1 means 5 silicon oxide tetrahedra are connected with 1 aluminum tetrahedron. Temperatures of over 400 degrees Celsius are needed to break this extremely stable oxygen-silicon-aluminum bond.
In addition to the 3 main elements, more than 30 different minerals can be found in small quantities in clinoptilolite zeolite, depending on the geographical location and mining area. The zeolite particles have many small cavities and channels, which is why zeolite is also labeled a microporous volcanic rock. The cavities and channels contain water of crystallization, that is, water that is not freely available, with various cations, that means minerals and metals with a positive charge, mainly calcium, magnesium, sodium, and potassium. These small cavities and channels have a defined size of 4 to 7 angstroms, that is 0.4 to 0.7 nanometers, and can bind pollutants and bring them to excretion. This is called adsorption. Selective here means that only those minerals and only in the quantity that are actually needed by the body are released, an intelligently controlled process.
Quality criteria of a high-quality clinoptilolite zeolite include: it is pure zeolite powder without any additives, the clinoptilolite content is between 90 and 97%, the surface area is 400 to 600 square meters per gram, a laboratory analysis was carried out, a silicon-aluminum ratio of at least 5:1 prevails, the CEC, that means cation exchange capacity, is over 200 mg per 100 gram. It is available as an ultrafine powder. The declared particle size is 5 to 8 micrometers, and the range of particle size is between 1 and 30 micrometers.
What is the difference between adsorption and absorption? Adsorption means superficial accumulation and binding. Absorption means a penetration of a substance into the interior of a material and possible dissolution. Adsorption and ion exchange have a mutual effect, and in this they use van der Waals forces, physical adsorption through electrostatic interaction based on ionic charge, chemical adsorption, for example the making of chemical bonds between the metal ions and molecules of amino acids, peptides, etc. The ion exchange takes place because pollutants have a great affinity to the crystal lattice of the zeolite due to their physical and energetic properties and are bound there. At the same time, the cations in the crystal lattice, such as calcium, magnesium, sodium, and potassium, are strongly attracted to the organic substances in the organism and thus selectively released. The crystal lattice loaded with heavy metals and other toxic substances is excreted with a stool. Excess particles or particles not loaded with pollutants are also excreted in the stool. Thus, overdosing is not possible. Of all the zeolite rocks found in nature, clinoptilolite zeolite carries out the ion exchange reactions with the greatest speed. Due to the defined and calibrated pore size of 0.4 to 0.4 nanometers, vitamins, amino acids, and polyunsaturated fatty acids are not removed from the body because they are too large or are not bound. Only harmful substances and toxins are removed.
Properties and functions of clinoptilolite zeolite. It binds and excretes pollutants by adsorption. It leads to ion exchange, that means the selective release of minerals and cations. It supplies the body with colloidal silicon dioxide. It regulates the metabolism of minerals and the acid-base balance. Ion exchange ensures bioelectrical activity and electrolyte balance. It neutralizes excess free radicals and oxygen radicals. It detoxifies heavy metal compounds, aluminum, ammonia, dioxin, and many other pollutants. It leads to an increase in physical and mental performance, the regulation of digestive functions, weakens the undesirable side effects of classical pharmaceuticals such as chemotherapy and antibiotics, and binds radioactive elements in radionuclides. It also tightens the skin and keeps it young, gives hair a new shine and in the long run more fullness. It plays an important role for our bones, muscles, tendons, ligaments, and fasciae. Colloidal silicon dioxide regulates water retention, purifies it, and leads to an improvement in the nutrient supply.
Zeolite, the path through the digestive tract. When the zeolite suspension is inserted in the mouth, an ion exchange and the binding of harmful substances already take place via the oral mucosa, which increases oral hygiene. Once in the stomach, the zeolite suspension leads to an increase in the pH value from approximately 1 to 5.0 or 6.5. In the stomach, the slightly acidic environment of pH 5 to 6.5 causes the formation of colloidal silicon dioxide from the anion tetrahedra. The aluminum tetrahedra are transformed in the stomach into aluminum anzides, so-called acid binders, or neutral aluminum compounds, which are excreted with the intestinal contents. The process of aluminum neutralization in the crystal lattice of clinoptilolite zeolite has been described in the same way in scientific literature as early as 1982, independently by 3 different sources.
Summary of aluminum neutralization. Due to the acidic environment in the stomach, Al3+ is released and combines with OH groups outside the crystal lattice to form AlO3. The stomach hydrochloric acid converts this compound into aluminum chloride. The antacids aluminum hydroxide and aluminum carbonate can be formed, which are then excreted in the stool as insoluble substances. If further Al ions remain, they are firmly bound and neutralized by the SiO2 molecules present in excess due to their affinity to silicon dioxide. These processes take place in addition to the ion exchange. The dissolution of elemental aluminum is completely excluded in these processes. This state of knowledge is now generally scientifically recognized and is described, for example, in the textbook Pharmacology and Toxicology from 2011.
In the small intestine, secretions from the pancreas with a pH value of 8.0 and from the liver and bile are supplied with a secretion with a pH value of 7.0. In order to be able to fully utilize food, a pH value of 8.0 must constantly exist in the small intestine. The selective ion exchange for clinoptilolite zeolite also requires a pH value of 8. In addition to the selective ion exchange, the binding, detoxification, and biocatalyst function for the nutrients in the intestine take place in the small intestine. The particles of clinoptilolite zeolite loaded with harmful substances are excreted. There are supposed to be studies that show that taking zeolite can cause larger amounts of aluminum to dissolve, enter the body and tissue, and be deposited. But in vitro studies in the laboratory cannot simply be transferred to the human metabolism. Our metabolism is very dynamic with complex interactions.
The in vitro studies that show that aluminum is released in higher concentrations when zeolite reacts with our gastric acid have nothing to do with the biological reality. Even if we have a pH value of 1.0 or 1.5 in the morning, and we drink water, which has a pH value of about 7, then the pH value in the stomach immediately increases towards 4 to 6.5, and a zeolite suspension automatically increases the pH value in the stomach towards 4 to 6.5, so that aluminum cannot be released at all in this concentration, because it is still only a slightly acidic solution.
It is impossible under normal physiological conditions to dissolve aluminum from the stable and solid lattice structure in relevant quantities in the stomach with 200 to 300 milliliters of a zeolite water mixture. If aluminum is released in small quantities in the slightly acidic environment of the stomach, it immediately forms new, insoluble aluminum compounds which are excreted in the stool. The aluminum content in food, including fruit and vegetables, on the other hand, is much higher. There are countless studies that show how harmless clinoptilolite zeolite is and highlight its profound detox and detoxification properties without the danger of overdoses, even when taken over decades.
How can zeolite be consumed? Add 3 grams of zeolite powder to 250 to 300 milliliters of pure water with a wooden, ceramic, or plastic spoon and stir. Metal spoons should not be used for stirring. Take a sip and keep the zeolite suspension in the mouth for about 10 seconds, then swallow. Stir again and take a sip until the glass is empty. Clinoptilolite zeolite as a source of silicon. A few important facts and graphics.
When can you take zeolite? 30 minutes to 1 hour before breakfast and before dinner, or 30 minutes to 1 hour before lunch, plus immediately before going to bed. How much zeolite can you take? When used as a detox cure, you can take zeolite over a period of 60 to 90 days at a dosage of 6 grams to 10 grams per day. For permanent use, you can take 3 to 10 grams per day, depending on age, weight, dietary habits, and living conditions.